Hey guys, so today you and I are going to talk about code generation. So let's get into it. So the question in question was, Frederick, are there any potential downside of machine learning code generation? Well, I would say the big downside is that it's gonna be a while before the code generators are going to be, because that's sort of the problem. Uh, Current machine learning, guys, is way too dumb to be able to generate code at the same level as a human. Let me explain that a little bit. So the fundamentals of code generation, or it's not really code generation, it's machine learning and generating it whatsoever, is that you are in essence training a AI, or like a machine learning model, to be able to produce some type of result that based on not actually knowing what the answer is. Now the problem with that is that you need something that knows the answer. And if we take a simple thing, which is the popular trend right now at the very least, which is to generate art or images or things like that, this is a fairly simple problem in comparison because the evaluation is almost nothing. You can evaluate with fairly high accuracy if a picture, for example, that has been generated by an AI is going to include the picture of a cat, just as an example. And the reason being is because it is a simple matter of classifying whether or not the picture is a cat or not, in comparison to classifying whether code is correct or not. Now the reason why I argue that is because the average software project, the average code that you might be writing, is actually not a cookie cutter process unless you have a fairly narrow scope of the algorithm that you're building. So let's say, for example, you're going to create a Fibonacci algorithm, or you're going to create a loop that counts a number or something like trivial like that. Then yes, generating code that can do that is a fairly straightforward process, because one part is that the code itself being classified, or like the correctness evaluation, can be narrowed down fairly simply, because you can process all the potential output of, say, a function or something like that. Let's say for a simple scenario it's a pure function, and evaluate whether or not you have the right the right algorithm. It's basically something you can break it all the way down to checking mathematical correctness. Now that is completely impossible for a non-standard problem. The reason why it's not completely impossible is because in real software projects you have functionality that both is like, you might have databases, you might have integrations, you might not know what all the possible outcomes of an algorithm can be, all the possible inputs. You may not even know whether or not something testifies as a bug or not, because you have no way of creating an efficient evaluation of whether or not the system is doing what it's supposed to be doing. As an example, when you have a stakeholder who comes in and asks you to write some code that, say, you're going to create a a website that where you can sell products or anything like that, right? The amount of code that is involved there and all the specifics of what that actually means is actually very difficult to determine, and that's why you usually have, like, this is the idea of MVP and like small iterations and so forth, where you build something, show it towards the user, hope that that is the correct thing, and then you continue doing that process, and a lot of quote-unquote bugs that might be introduced comes down to, in many cases, one part is of course a programming problem, there's a programming mistake on the programmer's side, but also unspecific specifications where there's room for interpretation. Now imagine trying to teach a AI how to create a simple shopping site and generating that code. How can you trust that the code is doing what it's supposed to be doing? Well, the the reality is that what you will have to do is that you will have to have websites that do basically this thing. You would have to go through millions and millions. I mean, let's just say this, guys. If you think it's a big task to figure out if a picture contains an object or not, where we were talking about hundreds of millions of pictures in order to do this accurately at the levels that we are today, imagine all the possible ways someone can implement a shopping site, and the code included. And you start to see my point. We are at a stage right now where like generating code is actually going to, and I'm guessing for a very long time, stay less efficient than having a human who actually knows how to do it. Because the other part, as I said, is the evaluation of the code. If someone generates code for you, like an algorithm does it, and you are going to actually run that code, it's probably good that you know what it's doing. And the question then becomes, this is one of the philosophical questions. So now you have something that generated code that works, or quote unquote works, but you have no efficient way to validate at large scale, unless, as I said, unless it's a really simple problem. How do you know that it's actually going to do the thing that you're expecting it to? Well, that's where you have unit testing, you have all these sorts of things, which are human rights, because the human knows the specification. The human should know what is supposed to be happening. The AI doesn't know fuck all about that. It knows nothing. It has guessed its way until it got to the point where it's doing something. As I said, there has to be a feedback system. So now you have to know what the AI wrote. And that brings us back to, if the AI generated the code, do you understand what the code is doing? Can you read binary? Because that is the exact, it is in essence the thing you're doing. Source code as we know it, guys, it's just for us humans, something that we need in order to understand how to express code in such a way that the computer understands it. And now we're basically doing we're going full circle. So now the computer is trying to create code for us so we can tell it if it is correct. It's just that, how is that thing going to put that in are you sure that it's going to be able to put that in a format where you feel like, yeah, I completely understand what's going on here? And you can't even ask it what it's trying to do. You have to figure it out on your own. So the likelihood, this is why I tell people like Copilot and these sorts of systems, these are very cool ideas, and I think that we're basically getting to a point where we're almost getting into the area of science fiction, but it's actually happening. It's just that we are so far away, I argue, from the point where we're going to be able to use this as an efficient way of producing software with today's levels of complexities. It is way, way, way too early to look at this as some type of feasible tool for that. I mean, I would even go as far as to say, based on the autocomplete features and functionalities that we have today, I would say it's borderline that I actually don't like it at all. Because, as I said, the AI does not know what I'm trying to write. And so what it's going to do is it's going to try to guess what I'm trying to write. And by the time it gets the guess right, I could have most likely just written the code myself, because I still have to correctness check the code the AI suggested to me. That's the downside. So what I want you to take away from this is that the potential downsides of machine learning code and code generation is that it's simply you have a very finite space of where it's going to be useful to you. The idea and so forth it's futuristic, and I think that there is a lot of potential in it. But by today's standards, it is way, way, way away, too early to put a machine learning algorithm in charge of producing software at the sort of scales that we are producing it by today's standards. It's similar, as I like to make the argument today, guys, we are trying to teach AI to classify images or classify things as something, or generating some type of visual representation. And usually why we are doing this is because these are very simple problems. Do you think I would love to see if we could get to a point, like when we get to a point where a machine learning algorithm or an AI is able to comprehend complex human thought and make meaningful suggestions that make sense that's when we get real benefit from this sort of stuff. And I would argue when we start approaching those sorts of levels, then we're basically at a point where we should start asking ourselves why we humans are making decisions that are most likely more suitable to be made by computers. I mean, to give you an analogy, today most people trust their calculators to give them the right answer, because you're never going to go and like check the fact like the calculator. But there's a world of difference between doing something like that and having a machine that is so intelligent that it, for example, knows how to optimize our health system, or knows how to distribute resources, or understand the complexity and nuances of human life to the point where it can make you feel like, yeah, this was really useful to me. This is where we're experimenting right now. But yeah, I think we still have some way to go. Have a great day.